Center of mass for you some regular bodies beta. First one is if I'm talking for your uniform circular ring, uniform semicircular ring, uniform semicircular ring. So the ring is something like this. This is its part on which it has been kept, and this is your axis. This one is its radius. There is nothing but capital R. This is your origin O. This is your semicircular ring. The center of mass is somewhere above on this one. So this is the position of your center of mass. That is the distance of your 2r divided by your pi. Actually, we are having a proof of this all by the Papas theorem beta, but that proofs are not all much required for your competitive examinations. Only thing is you need to remember them directly while doing the numericals part of relation. Okay, na? So don't waste time behind your derivations of all this basically. Then the center of mass of your uniform circular disk. Then we are talking about your uniform circular disk. Uniform circular disk. For the disk, there will be mass throughout the body. This one is again same condition. And the radius of this one is nothing but of your R. And center of mass will lie along y-axis. This is y-axis beta, YCM I think. Because it is along y coordinate. X coordinate.
Yes.
Then kuda center of mass ikkada act avutundi. But for this one, we are having mass kabatti we'll try to give little bit of a mass for this one. So there is a mass for this one. Okay. And mass, center of mass for this one is from here to here. This value is 4r by your 3 pi. In which direction? YCM. And third one is your hemispherical shell. Hemispherical shell. For hemispherical shell, the center of mass will be again same condition like now. This is your hemispherical shell. And this is your y-axis. The center of mass is exactly at the center of this one. That is at a distance of your YCM, and then this one is nothing but of your radius. So this one is of your YCM. So this YCM is equals to your R by 2, exactly half cavity. Okay, exactly at half it is your R by your 2. Total radius is capital R. R exactly center cavity, for that it is nothing but of your R by 2. Then fourth one, if I'm writing solid hemisphere. For your solid hemisphere. Okay, so solid hemisphere also is here right now. This one is its radius, capital R, and center of mass is somewhere here. This is your origin, again at the y-axis. So y-axis is equals to 3r by your 8. Okay, na? 3r by your.
Yes, sir. Yes.
So I'll make one general formula beta here right now. Center of mass of uniform circular, center of mass of a uniform circular arc of radius capital R, subtending an angle 2 alpha, subtending an angle 2 alpha at the center is at a distance, it is R into sine alpha divided by your alpha beta from center of curvature, from O, and it lies on bisector, and it lies on the bisector. Okay, so alpha in denominator has to be substituted in radians. Okay, so దీనికి diagram ఎట్లుంటుందండి, this is your arc అనుకుందాం. Okay, and this is your origin, center. దీనికి radius ఇది. Okay, this one is your alpha, this one is your alpha. So where is the center of mass? Perpendicular bisector. So this will be your center of mass. Okay, and alpha in the denominator has to be substituted in which angles beta? It should be taken in terms of your radians. It should be taken in terms of what? Radians part of relations. Okay na? Ante deentlo r into sin alpha divided by your alpha. Diagram lo kaadu. Alpha in the this one should be taken in terms of your radians.
Yes.
Okay, chalo. Fifth one is done now. So we'll try to take the sixth one. For uniform conical shell. For uniform conical shell. This one. I'll send you today one assignment on center of mass beta. You please try to complete that one. Okay. And this is your uniform shell. The height of this cone is right now for me as of your h. Then center of mass is again on y-axis. So here is your center of mass. So from vertex, if I'm taking, so from vertex, this height will be equal to your 2h divided by 3. This is the height of your h part definition. That means center of mass of the solid cone of height h is from base. If you ask the answer, what is the answer? From base, if it is h, so it is 2h by 3. h minus 2h by 3.
2h by 3. Yes.
h by 3. h by 3.
Yes.
Sorry, 4. H by 4.
Sorry, sir. Wait.
h minus 2h by 3.
Minus we'll.
Yeah, minus kabatti kindane vastundi kada.
Okay, 2 we'll get h only, sir.
h
we'll
minus
3
by 3 kada.
Yes, sir. So we'll get 3h minus 2h by 3, no, sir. So h by 3 only we'll get.
Okay, fine. So that you can do it out kada.
Yes, sir.
Okay, chalo. Next one. For a uniform solid cone, for uniform solid cone, or we can say pyramid of height h, same like previous one beta. Center of mass is equals to h by 4 from its base. Okay na? So for the one like this. Now this is completely a solid. So from base, it is at your h by 4. This is the center of mass. Okay na?
Yes, sir.
Triangular plates అవన్నీ కూడా ఉన్నాయి కానీ అది ఇంకా మెడికల్ పిల్లలకి పెద్దగా అవసరం ఉండదు. So don't take about the tension. But make sure that you have a difference between what do you mean by center of mass and center of gravity for your board exams. For board exams,
Yes,
there is a like a 2-mark, 4-mark question. Differentiate between the center of mass and as well as of your center of your gravity part deflection. ఒకసారి ఐపీ మెటల్ కూడా తీసి చేయడానికి ట్రై చేసి సరిపోతుంది బేసికల్. ఓకేనా?
Okay. Yes, sir.
So by this we have been completely done your center of mass concepts. Today I'll try to send you one assignment based upon this one beta. You please try to complete that assignment related to given conditions. Okay na?
Yes, sir.
So what is the next topic? We need to start with it tomorrow.
Sir, fluids.
Fluid start cheskundama. Okay.
Sir, actually, vector product also we did, sir, actually yesterday in class.
నేను మీకు వెక్టర్ ప్రోడక్ట్ చేశానా?
Yes, మీరు చేశారు అనుకుంటా, సార్.
నేను యూట్యూబ్ లో పెట్టాను చూడు. You can
Okay.
find a lot of applications of that one. I'll try to send you the notes of vector product right now for you. You try to go through it. If you are having any doubts, you let me know. I'll try to help you out some problems related to that. Okay, na?
Okay.
Okay, chalo then. Okay, bye beta.